All right, so today we're going to do the 2006 free response number 5. It is non-calculator. This is going to be a slope field problem and a partial differential equation problem. All right, so we have the differential equation already on the board. dy dx is going to equal 1 plus y all over x. On the axis provided, we need to draw in our slope field. Okay, so let's start drawing those points in. Guys, remember, these are easy points for you, all right? So don't go too fast and screw something up. Make sure you do them correctly. All right, so as we go...
Go.
Grow up. All right, so this, I'm going to start here at, let's do 1, 1. So point 1, 1 is going to be x equals 1, y equals 1. So we're going to get 1 plus 1 all over 1, which is going to give me a slope of 2. So remember, at 1, 1, I want to draw a line with a slope as close to 2 as I can. So I always like to think about here, draw a line up. Should be approximately that slope. I'm going to go here next. This is going to be the point 1, 0. All right, so for the point 1, 0, that's going to be x equals 1, y equals 0. All right, so this is going to be 1 plus 0 all over 1. I should get a slope of 1 there. Should be about 45 degrees, going up like so. So guys, the big thing here is if that's a slope of 2, make sure that is more steep than the slope of 1. Going down here, this is going to be 1, negative 1 now. For 1, negative 1, y is going to be negative 1, so we get 1 plus a negative 1, all divided by 1, which gives me a slope of 0. Make sure that is a very horizontal line. Don't have any kind of slope to it at all. Just make it straight horizontal. The last positive one over here I'm going to do is 2, 0. So y is going to be 0. So we get 1 plus 0, all divided by x, which is 2. So it's going to be a slope of 1/2. So I'd be going normally up 1 over 2. Or I could think about it from here. I'd go up 1 over 2. Okay, the big thing here is that that is less steep than the slope of 1. Okay, if they're a little bit off, just make sure that they're all relatively how they're supposed to be compared to each other. Going over here, let's do negative 1, 1. Okay, so we get 1 plus 1 divided by negative 1, which is going to give me 2 over negative 1, which is going to be negative 2. So I'm going to be going down 2 over 1. Okay. Next one I'm going to do here is going to be negative 1, 0. So here we get 1 plus 0 divided by negative 1 is going to give me negative 1. So I want it to be 45 degrees as well. Make sure it's going down to the right. Okay, make sure this is more steep than that. If that was negative 2 and this is negative 1. 2 to go. We got negative 1, negative 1. Okay, so when I plug that in, I'm going to get 1 plus a negative 1 is going to be 0. All divided by negative 1, which is 0. So I want to have a horizontal slope here. Okay, the last one's going to be negative 2, 0. Negative 2, gamma 0. We get 1 plus 0 is 1. All divided by x, which is negative 2. So here we have a slope of negative 1/2. So I'm going to go down 1 over 2. It should just be less steep than this one. Okay, the way I drew that, that looks pretty similar. So I'm just going to adjust it a little bit more. Okay, now I can definitely tell that's less steep than that one. All right, so part B then is asking find the particular solution y equals f of x to the differential equation with the initial condition f of negative 1 equals 1. All right, so f of negative 1 equals 1. All right, like I said, this is our partial differential equation, or our separable differential equations, I should say. So I got to separate my variables. Okay, guys, if you screw that up, you just zeroed all these points. You got to make sure you separate this correctly. I want to bring my dx over here. I got to bring my 1 plus y over here. So I'm going to divide by 1 plus y. It's going to give me 1 over x dx. All right, make sure that these are in your denominator. Okay, you don't want to be adding and subtracting other things. Got to divide. At this point, we just want to integrate. If you guys really wanted to, you could do u sub here. All right, but there's nothing special happening. So when we integrate, we're going to get natural log of the absolute value of 1 plus y is going to equal the natural log of the absolute value of x, and you got to put your plus c there. Okay? So we had a couple different things. We can try to solve for y first, or we could plug in our value and then solve for c. I probably want to solve for c first. Okay, so remember, this is your x value, this is your y value. Make sure you plug them into the correct spot. So I've got natural log of the absolute value of 1 plus 1 is going to equal the natural log of the absolute value of negative 1 plus c. All right, so over here we get natural log of 2. I no longer need the absolute values on that. Natural log absolute value of negative 1 is natural log of 1. Natural log of 1 is 0. That essentially goes away, and c is going to be the natural log of 2. All right. So that's where most of our points are going to be coming from, but we still are supposed to give a specific solution. Okay, so we can go back, try to solve for y here. So here's my equation. We've got natural log, absolute value of 1 plus y is going to equal the natural log of the absolute value of x plus the natural log of 2. All right. So next thing you could do is exponentiate. Or do you want to combine these?
I'd exponentiate.
You'd exponentiate?
Mm-hmm.
All right. We can exponentiate.
Which you can do, you guys, because there's no coefficient in front of the natural log. If there were a negative or a coefficient in front of the natural log, you'd have to get rid of that first before you exponentiate. But we're good to go right here.
So we exponentiate, that goes away. I'm left with the absolute value of 1 plus y is going to equal, okay, this is going to be e to the natural log of the absolute value of x times e to the natural log of 2. All right, and what will happen with that is this is just going to turn into the absolute value of x because e to the natural log cancels off each other. And same thing for here, we're going to be left with a normal 2. So we get 2 absolute value of x is going to equal absolute value of 1 plus y. Just what I was saying there is that you could actually combine those with your logarithm rules. Just going back a step to show you what you could have done too. So that would be the natural log of the absolute value of 2x with your log rules. And then you exponentiate, and it's really the same thing. And you just bring that 2 back out. But anyways, whenever you get the absolute value, you're still going to solve for y. You got to solve it twice. Remember, the first way we're going to solve it is you just drop your absolute value signs. You got to keep this absolute value in there, though. Okay, and your second version is going to be, I'll just jump down here where there's a little bit more room. Replace your absolute values with parentheses and put a negative up front. Like so. Only one of those is going to work with our initial value. Our initial value, remember, was negative 1 comma 1. So when we plug that in, I'm just going to plug it in down here first. So y is going to be 1. So we get a negative. 1 plus 1 is going to equal 2, absolute value of negative 1. Here we get negative 2 equals positive 2 because our absolute value takes care of that negative 1. Okay, so that's not the version we wanted. We can just go and double check to make sure this one works out. Where it would be 1 plus 1 is going to equal 2. absolute value of -1. All right, and you can see here we're going to get 2 equals 2. All right, and that's the version we want. So we still need to solve for y. We just subtract 1 over. So y is going to equal 2 absolute value of x minus 1. All right. Ryan's going to talk to you guys about domain.
So before we talk about domain, let's just talk through the points, because the domain's the last point. And we've kind of told you guys, like, the domain's pretty hard. It's only going to be 1 point. Don't stress about it. So let's talk about where the other points come from. And if you got all the other points, this, remember, was a while back. So some of the way they awarded the points through here would be a little different at this time when you guys are taking your exam in 2020 versus 2006. But it's only A and B is the bulk of the points. Man, if you can get those, you can do really well on this kind of problem out of 9. So the slope field was 2 points. And they're probably going to specifically look for, it didn't have a specific breakdown on the rubric, but were the ones that had a slope of 0 correct. And that would be 1 out of 2. And then were the other ones relative steepnesses correct and the direction correct. So were these all positive slopes? Were these all negative slopes type of idea? Okay, so then Mr. Herney already reminded you, the first point is going to be that you separate your variables. If you don't separate your variables, then they won't keep reading with you and you haven't graduated into earning any points. For this year, it was 2 points for the antiderivative. So you got a point for each side, and they don't always do that anymore. This one's fairly easy. Nowadays, this would probably require at least u sub on one of the sides, would be my guess. You get a point for your plus c in the right location. So as soon as you're done integrating, that plus c has to be there as your constant of integration. Otherwise, it's called a c of desperation. You get a point for using your initial condition correctly, which is why you want to plug it in here instead of trying to solve for y first. Because if you screw up solving for y, you don't get that point. So that you use your initial condition. And you do have to make sure you get the 1 in place of the y and the -1 in place of the x. But that's a pretty soft point to earn. And then your last point is, after you determine which version you have to use, that you use the appropriate version and you solve all the way for y correctly. So the last point is where you actually get the y equals 2 times the absolute value of x, and behind that a -1. So a lot of points going on right there. And then the last point is going to be the domain. So I'm going to try to talk through the domain. I don't know that it's perfect, but some of you might be able to kind of have a gut feeling. And if you kind of have a gut feeling, go with that. And if you don't have a gut feeling, then don't worry about it. So if you look back at your slope field and we think about our initial condition being -1, 1, right? Even though we don't have a very big slope field, can you guys tell this side is kind of symmetric with this side, but the opposite way? So our initial condition was -1, +1. So even though I don't really see a lot of the slope field to go, well, what kind of curve would make it go through there? I know this kind of is coming down. I don't know what else is going on, but I'm on this side of the graph, whatever's happening. So the domain, if that's where the initial condition is, seems like it would have to be from -infinity up to here, because this side would be the whole other symmetric side if you were on this side of your y-axis. So the domain is from -infinity to 0. Some stuff back up here, remember, was natural log, and you can't take the natural log of 0, and there's a vertical asymptote, and there were no dots on the dot grid here, because on the differential equation that would give you undefined or trying to divide by 0, so that's why we can't include 0. Like I say, it's kind of a crapshoot about whether you can get it or not, but I think some of you can follow, okay, we're on that half of the slope field, and that half is where x is less than 0, or an interval notation from -infinity to 0. And remember, on AP, you could write interval notation, or you could write inequality notation. So if you wrote where the domain was x is less than 0, they would give you that point. It's only ever going to be 1, so don't stress about the domain thing. If it's on there, fine. If you get it, if not, okay.
One last thing, guys. I just want to talk about this one more time. So they didn't give you points here because they're vertical tangents, all right? But sometimes they might try to trick you and put some points on there. Okay, don't draw your vertical line if they give you those points. Okay, remember, it's a vertical tangent, it's undefined. You're going to lose points if you end up drawing a vertical line on that.